In the last part of this section, we are going to be working through some application problems. So go ahead and pause the video and read through the story problem. Okay. Now, as we read through this, when it's talking about the ball being thrown from an initial height of 3 feet, so in the picture, that's what this line is representing. And then we know that if we are throwing a ball upward with any velocity, that at some point it's going to have to come back down to the ground. Okay. So when it's asking us to find all the values for t, which is talking about the time it takes for the height to be 19, we know that it's going to be 19 at 2 different times. So it should be hitting 19 on the way up and then somewhere again on its way back down. Okay. Now, the only time that it would hit this height once is if it happened to be the vertex. But for these problems, we should be assuming that this will not be the vertex. Okay. So again, we're looking at those 2 points right there. So to figure out the time, since they're telling us the height is 19, we are just going to substitute this height into the given equation. So this will be 19 equals 3 plus 34t minus 16t squared. And then now we are just solving that quadratic equation. So to solve the quadratic equation, everything needs to be on the same side equal to 0. So I'm going to have to start by subtracting 19 over. So we have 0 equals negative 16 plus 34t minus 16t squared. And now we're just using our quadratic formula, or if you would prefer, you could also solve by completing the square. But usually for these problems, the quadratic formula is going to be faster, especially knowing that we need to round our answer. Okay, so these are not going to work out nicely, so you will need a calculator for these. So remember, a is always with our squared term, b is always with the variable without the exponent, and then c is the number without a variable at all. Okay. So instead of using x, I'm going to use t since that's our letter that we are working with. So t equals opposite of b, so that will be negative 34, plus and minus the square root of our b squared. So 34 squared is 1,156 minus 4 times a, which is negative 16, times c, which is also negative 16. And that is all over 2 times a, so 2 times negative 16. So t equals negative 34 plus and minus the square root of something over negative 32. Okay. So I'm just typing in what's underneath the radical, not including the radical. And I'm using my negative key for those negative numbers. So this is 132. Okay. Now, because we're going to be rounding, we don't need to worry about simplifying the square root at all. We can just start that calculation. So we will need to separate this. So this will be negative 34 plus the square root of 132. And then since we're going to be typing this into the calculator, I'm going to put the top part in parentheses, and then we will be dividing by the denominator, so negative 32. And then we'll need to go back and figure out negative 34 minus the square root of 132. So again, this part needs to be in parentheses since it represents the top part of that fraction. And then we will divide by negative 32. Okay. So again, we are coming up with an approximation. So I'm going to use my squiggly equal signs. So that's the sign that we rounded. And according to the directions, we need to round to the nearest hundredth. Okay, so it is important that you are rounding correctly. Otherwise, when you do this topic in ALEKS, it's going to count your answers wrong. Okay. So to type it into the calculator, I'm making it look exactly like this. So I'm using a parenthesis, negative 34 plus the square root of 132, and then notice how this has a little arrow on it. So I need to arrow to the right to come out from underneath the radical sign. Now, if you have an older calculator and you don't see that symbol, then you have a parenthesis to start with, make sure you are closing your parenthesis after that point. Okay. And then divide by our negative 32, so I need to make sure I'm using the negative key at the bottom, and then we are pressing enter. So this will be 0.70 for rounding to the nearest hundredth. And then you can retype that all in and then use your minus key instead. Or what we can do is kind of copy paste it. So as long as you don't press anything after this, if you press second enter, it will copy and paste your previous line. And then I can just arrow back and change this to be the minus sign and then press enter. Okay, so this will be 1.42. All right, so to answer the question, for all the values for t, which the ball's height is 19 feet, our answers would be at 0.7 seconds and 1.42 seconds. All right, so go ahead and pause the video and then read through this next problem and start working on solving it. All right, so we have a model rocket that's being launched. Now, again, at some point, it's going to have to come back down to the ground. Okay. And this is asking us to find all the values of t for which the rocket's height is 78 feet. So again, I know at some point it's going to hit 78 feet going up and then 78 feet on the way down. So since I know the height is 78 feet, I'm plugging that into the h in the given equation. So we will have 78 equals 138t minus 16t squared. Okay. And then we are just using the quadratic formula to solve that. So I need to start by subtracting that over. So 0 equals negative 78 plus 138t minus 16t squared. So negative 16 is A, 138 is B, and negative 78 is C. So x will equal negative 138 plus and minus the square root of 138 squared, which is 19,044. And then minus 4 times A, which is negative 16, times C, which is negative 78. And that is all over 2 times A. So 2 times negative 16. So x equals negative 138 plus and minus the square root of something over negative 32. Okay. All right, so again, we're just using our calculator. So 19,044 minus 4 times negative 16 times negative 78. So 14,052. Okay. And then we're looking for 2 answers, so we're going to need to separate this. So this will be, and again, I'm going to use parentheses, negative 138 plus the square root of 14,052, and then divided by negative 32. And then negative 138 minus the square root of 14,052 divided by negative 32. All right, so I'm going to hit clear, and then I'm just going to type this top one in. So parenthesis first, and then using my negative key at the bottom. So negative 138 plus the square root of 14,052, arrowing to the right to come out of the radical, closing the parenthesis, divided by negative 32. Okay. All right, so our first time is 0.61 seconds. Okay. And then I'm going to press second and the enter key to copy and paste. And I'm just arrowing back to change my plus sign to a minus sign and pressing enter. So the next one is at 8.2 0.02 seconds. All right, last problem. So go ahead and pause the video, read through it, and then you can start working on setting it up. All right, so this time our ball is thrown from a height of 110 meters with an initial downward velocity of 6 meters per second. So the question is asking us, how long after the ball is thrown does it hit the ground? Okay. So this time, we should only be finding one answer, but the process is going to be the same. So if we're trying to figure out after how long the ball is thrown that it hits the ground, that means at the ground our height is 0. So I'm just substituting 0 into the height. Okay. And then we're still going to use the quadratic formula to solve. So this is my A, B, and C. So T will equal 6 plus and minus the square root, 36 minus 4 times A times C, and that is all over 2 times A. Okay. So now we're just working through simplifying. Okay. So this will be 36 minus 4 times negative 16 times 110. So 7,076. Okay. And then we're going to need to split this up into 2 different parts. So again, we'll do 6 plus the square root of 7,076, then divided by negative 32. And 6 minus the square root of 7,076 divided by negative 32. Okay, so starting with that top one, 6 plus the square root, 7,076, arrowing to the right to get out of the square root symbol, closing the parenthesis, divided by negative 32. So this one is approximately negative 2.82. And then I'm pressing second enter to copy and paste, and then just arrowing to the left until I'm over that plus sign and changing it to a minus. So this is 2.44. Okay. Now remember, we are dealing with time, so we can't have a negative time. So that means that my only answer to this would be 2.44 seconds. Okay. Now the reason why this one is a little bit different than our previous two is because in our previous ones we were starting either at the ground or close to the ground and throwing it up, so it's making this arcing. Whereas on this problem, we are starting at our vertex essentially and throwing it, or closer to our vertex and throwing it down. So as far as our time goes, we're up a lot higher when our time is 0. So technically the other arc is in the negative time, which we know isn't possible. So that's why we only have the one answer for this. Okay. And anytime we are dealing with these types of problems, we should not have a negative answer if we're talking about time. So you would only include your positive answers for these. Okay. And that is going to conclude this unit.